Oh, so this redox reaction is giving you some problems. Let's handle it. This reaction, if you look at it, is pretty complicated. You know, balancing this thing is going to be a challenge without a little bit of help. And the help that we're going to get is using oxidation and reduction. First step, this is the one that's probably the most time consuming, is trying to find out the oxidation numbers of the substances in this compound. Now, you don't need to find them all. All you got to find out is which substance is being oxidized and which substance is being reduced. So let's get a couple of oxidation numbers here. Let's look at the silver. This is an easy one. It's a single atom. It's got a charge of plus. So the oxidation number is +1. Now let's see what happens to it. Let's see if it's changed. Oh, here it's an element. In fact, look for elements because they make oxidation reactions easy, because you know an element's going to be an oxidation number of 0. And in a reaction, if there's an element, it's undergoing an oxidation or reduction. Let me see here. +1 to 0. Okay, that's a reduction. The number is reduced. Let's look at the next thing. Here is something unusual, arsenic. You don't see arsenic in a lot of compounds. You see hydrogen a lot. And one nice thing about hydrogen is that it's almost always +1 unless it's an element. So we know the hydrogen right here, which is attached to the arsenic, is a +1. There are 3 of them. So the total positive charge in this redox compound is a +3. They got to add up to 0 because this compound is neutral. So the arsenic is a -3. That sort of makes sense. Arsenic is sort of like in the middle of the periodic table. It's underneath nitrogen. But let's see what happens to arsenic to see if it's changed. If it's changed, then we're pretty well set. Here's the arsenic on this side. Now it's paired up in this compound with some oxygens and hydrogens. Now the oxygens almost always are -2 unless they're an element. Come on, -2. There's 3 of them. That makes a -6. Arsenic, again, we're not sure about. That's what we want to find out. Hydrogen, again, is a +1 unless it's an element. That's 3 of them. That's a +3. This entire compound is going to add up to 0. That's pretty easy. A little bit of math. There's arsenic with a +3 charge. There's only one arsenic, so its oxidation number is now a +3. Now let's look at it before. -3, moving up to a +3. It went up. That's all we need. We need one compound that's going down, reduced, another compound that's going up, oxidized. This is it. I don't have to do anything else. Anyway, you can see oxygen and hydrogen here. They're not going to change at all. So let's end up taking those 2 parts right now and see what's happening to the silver. The silver, Ag, +1, turning into Ag, Argentum, Argentina, the land of silver. To go from a plus to a 0, you need a minus. So we're going to add 1 electron. Silver is very, very good at picking electrons up. And in fact, that's why silver rings stay nice and shiny, because they're not going to lose electrons. They're going to stay pretty metallic silver. Here you've got this solution of silver ions turning into metallic silver. Very, very pretty reaction. That's 1/2. We would call this the reduction. I'm going to just write down red for a reduction, red and red. Arsenic. Now this thing better be oxidizing, because if one substance reduces, the other one's got to oxidize. You can't have one substance gain electrons without something else losing electrons. That's the two. That's why it's 2 half reactions. Let's write our arsenic. It is a -3. Now because the silver is reducing, we know the arsenic has got to be oxidizing. Its number is moving up the number line to a +3. To do that, it had to kick out some of these electrons. We're going to kick out the electrons. That's going to be a total of 6. 6 electrons. And that's our ox, which we have to have. Right now, you've got 90% of this problem solved. You've got the tough part solved. You found the reduction. You found the oxidation. There's only 2 halves to a redox reaction. The thing is, though, that you can't end up giving away 6 electrons and only picking up 1. You'd have 5 orphaned electrons. This thing would be shooting electrons out all over into the world. There'd be lightning bolts coming out of it. So the silver has got to pick up those 6 electrons. And each silver picks up 1. We multiply the silver by 6. So 6 silvers for every 1 arsenic. A little unfair, but that's fine. So now we can go balance the reaction, because we know there's going to be 6 silvers for every 1 arsenic. Let's go up to our original reaction here. 6 silvers 6 silvers. We're going to have just 1 arsenic. So this is going to be forced into a 1, and this is going to be forced into a 1. And that's really the heart of the reaction. Pretty much that's all you'll have to do on most AP questions. But this one might ask you about the hydroxide, because there's another part here. Notice our compound products are all neutral. The charge of the products is 0. Now, we've got a +6 for silver ions here, a neutral arsine molecule. So we're going to need 6 hydroxides to neutralize the reactants. Now, in this problem, I already had the water with a 3 here, so we're set. This is a very, very challenging redox reaction. We've taken care of it, and all set. Balance our redox reaction.